Welcome all of you to another video of Maths Made Easy. Now in this video we are going to take up multiplication of rational numbers. Once again from R.S. Agarwal, we are doing the chapters of R.S. Agarwal serially from the beginning. So this is multiplication of rational number and the exercise based on multiplication of rational numbers. So here in this I have, this is exercise. This is exercise 1D from rational numbers. Okay, so as I said, if you are following some other textbook, no problem, you can still follow the videos and you can do the exercises from your textbook, because all the sums will be explained no matter which textbook it is. You will get the sums in your textbook, you'll be able to do them. Okay, before this we have done addition of rational numbers. So now today we are going to take up multiplication of rational numbers and the properties based on multiplication of rational numbers. In the last video we did properties based on addition of rational numbers. Okay, so almost the same properties get repeated here with a few new properties of based on multiplication. Very important. Towards the end of the video you will get that, so please watch the video from the beginning to the end to get a clear understanding. Okay, so let us start then. Firstly, we will do some multiplications of rational numbers. How exactly we do multiplication of rational number? 3 by 5 into minus 7 by 8. You have to multiply. Now the multiplications are very much like fraction multiplication. We have to see the numerator and the denominator. Does it cancel? Any numerator can cancel with any denominator. And we have to also multiply the signs. We have to follow the sign convention. Minus into minus is a plus. Minus into plus is a minus. Plus into minus is a minus. And plus into plus is a plus. Okay, so we have to follow this sign convention every time. So here it is plus, nothing is there means plus, into minus, that is a minus. But then nothing cancels. If you see 3 and 8 and 5 and 7, there are no common factors. So what do? Okay, so we just have to multiply numerator with numerator. So 3 with 7, 21, and 5 with 8, that's a 40, and plus with minus, that is a minus. So this is all we have to do. Okay, we did the same thing in fractions also. Minus 2 by 3 into 6 by 7, same again. Okay, so here luckily the 6 and the 3 cancels, so with a 2. Okay, minus with a plus. This rational number was minus, that was plus. Okay, so now that makes us how much? Minus. Okay, now nothing else is cancelling. No numerator denominator is cancelling. 2 into 2, 4 and 7. Minus 4 by 7 is my answer. Okay, so this is how we multiply. Let me take another one quickly. Minus 13 by 15 into minus 25 by 26. Okay, here we have negative with negative, answer is going to be positive. 13 and 26 cancels, so 2, and this is 5 with a 5 and a 3, so this is 5 by 6. Okay, 5 by 6 is my answer. So 5 by 6 is my final answer. Okay, now let's come to the properties of multiplication. Okay, what are the properties of multiplication? Now the properties of multiplication of rational numbers go like this. Supposing I have half and I multiply with 5 by 7. How much do I get? 5 by 14. Now this was a rational number, this was another rational number. Okay, so therefore, and we see this is also another rational number. Therefore, multiplication of rational numbers follow closure property. Okay, closure property, or rational numbers are closed under multiplication. Before this, in the last video, we have done closed under addition. Now this is closed under multiplication. Let me take few more examples. Minus 3 by 7 into 5 by 14. Now see here. Nothing cancels. Minus 15 by minus 15 by 98. This is also a rational number. These two are rational numbers and the answer is also a rational number. Hence closed under multiplication. Okay, if we take another one, minus 4 by 3 into minus 7 by 3. Again, this is a plus 28 by 9. Again, we can see that this also is a rational number. Hence, rational numbers closure property is satisfied. Okay, so here this is closure property is satisfied. So here we have, so here we can see that both were positive, closure property followed. One positive, one negative, still followed. Both negatives, even then it is followed. So rational, for all rational numbers, closure property works. That was our first property. Okay, let's move on to the next property. Okay, commutative property. So commutative property is simply this: A by B into C by D, if I write algebraically, is C by D into A by B. Your teacher might have given this to you and you might be thinking, what is all this? Okay, so this is nothing but here we have one rational number, here we have another one. First you multiply A by B first, keep it to the left, multiply, and if you keep this to the left and that to the right, even then you get the same answer. We are going to prove it with the help of examples now. So here minus 2 by 5 into 6 by 7. How much is it? Nothing is cancelling. Minus 12 by 35. Let me do the other way now. 6 by 7 into minus 2 by 5, which is minus 12 by 35. Do you see? Therefore, minus 2 by 5 into 6 by 7 is equal to 6 by 7 into minus 2 by 5. Hence, commutative property is satisfied. Okay, so A by B is B into A. A into B is B into A. Okay, now let me take up associative property. One example for associative property. Now in associative property we have A by B into C by D and bracket here into D by E, which is A by B into C by, oh my god, sorry, is A by B into C by D into E by F. We put a bracket here. Okay, and note all the signs are multiplication. A by B into C by D into E by F. Yes, okay, into E by F. So this is associative property. So this is associative property of multiplication. One rational number, another rational number, another rational number. Multiply these two first. With the product, multiply this. Whatever is in bracket always should be done first according to Borman's. Now multiply these two first, with the product multiply this, and you should get the same answer. So now I am going to do it with the help of an example. So minus 5 by 2 into 7 by 4 into 1 by 3. Okay, so bracket first, this is, I am doing that side. This is, does it cancel? Nothing cancels. Minus 35 by 8. Okay, into 1 by 3. Does anything cancel? Nothing cancels. Minus 35 by 24. Okay, now let me do this side. Minus 5 by 2 into 7 by 4 into 1 by 3. Minus 5 by 2. Seven by 12. Minus 35 by 24. Okay, minus 35 by 24. So this is, see, note both are equal. Therefore, this is followed. Hence, these two are equal. So associative property is followed. You can check this for, even if we have a negative here, it will still work. All three negatives, then also it is going to work. It works for any rational number. Okay. Now, existence of multiplicative identity. Okay, existence of multiplicative identity. What is multiplicative identity? Let us see. So here all rational numbers, supposing it is a by b is into 1 is equal to 1 into a by b, which is equal to a by b. Now in very simple words, every rational number if multiplied with 1, okay, whether you write 1 first or the rational number first, it will always give you the same rational number. Do you note this? Minus 2 by 3 with the 1, or 1 into minus 2 by 3 finally gives you this minus 2 by 3 only. Okay, hence 1 is the multiplicative identity. Okay, remember it stays same for the entire set of rational numbers. Only one multiplicative identity, and that is 1. Okay. Now the next one is existence of multiplicative inverse. What is multiplicative inverse? Okay. If it is a by b into b by a, it is b by a into a by b, which is always equal to 1. In other words, if I have 2 by 3, then the reciprocal is the number with which if you multiply this to get a 1 is the multiplicative inverse of this number. So for this number, the multiplicative inverse is, for 2 by 3, the multiplicative inverse is 3 by 2. Okay, let me now take minus 2 by 3. Okay, in order to get 1, I will have to multiply with minus 3 by 2. Okay, so the multiplicative inverse of minus 2 by 3 is minus 3 by 2. Hence, multiplicative inverse is nothing but the reciprocal. Okay, remember one thing, if the number has a negative, the reciprocal should also have a negative. Only the numerator becomes the denominator becomes the numerator. I repeat, multiplicative inverse is that number which when multiplied with a number gives a 1. Okay, not a minus 1. Now this is distributive law of multiplication over addition. This is the most important, very, very important property. Okay, because most mistakes happen here. Now this says a by b into c by d plus e by f. Okay, that is a by b into c by d plus a by b into e by f. Okay, so here this is the distributive law of multiplication. Because of this sign, multiplication over addition. Addition is here. So multiplication over addition they are saying. Okay. Now what is it all about? It is basically a shortcut that we use. Okay. So let's try it with some numbers. Minus 3 by 4 into 2 by 3 plus minus 5 by 6. So I am here. Look at it. Look at the similarity. Okay. I will do that first. Minus 3 by 4 into, this is 6 here, and this is 4 plus this is 6 and 6. This is minus 5. Okay. So minus 3 by 4 into 4 plus minus 5. How much is it? So minus 3 by 4 into 4 plus minus 5 by 6. So I have, so here minus 3 by 4 into minus 1 by 6. This is 2. This is 1 by 8. Okay, so 1 by 8 I get on this side. This part of it comes to a 1 by 8. Let me try out this part now. So now let me do this side. Minus 3 by 4 into 2 by 3, first part, plus this part. Okay, then minus 3 by 4 into minus 5 by 6. That is, cut this. This is a 2. Cut this 2. So I have minus half plus, this is plus, minus into minus plus 5 by 8. This is 8 here, minus 4 plus 5, which is 1 by 8 again. So from this side also I got 1 by 8. From that other side where I have taken this part and multiplied with both separately, there also I have got 1 by 8. Hence, distributive property or law is followed for multiplication over addition. Okay. Multiplicative property of 0. Now here I have, okay, it is very simple. A by B into 0 is 0 into A by B, which is equal to 0. In other words, any rational number you take and you multiply it with a 0, you are going to get a 0 only. Or 0 into any rational number, you are still going to get a 0. You take it as a negative, then also no difference. Okay, even if you take it as a negative, you still get a 0. This is the property, multiplicative property of 0. That is it. So with that, we are done with properties of multiplication of rational numbers. Okay, in the next video, I shall be starting with few sums based on the properties that we learned, that is the commutative property, the closure property, the associative property, multiplicative inverse, multiplicative identity, and property of 0. So we shall be doing sums based on this in the very next video of rational numbers. That's it for today. If you've liked the video, do not forget to like, share and subscribe. Also leave a comment behind if you like the video. Okay, that's all. Bye then.